Okay, let's use a number of skills to get a sketch of this graph. I'm not going to use x or the axis intercepts, okay? You know what to do for them. You just make x equals 0, you make y equals 0, and you do them. But what I'll do, let's see what information we can gather. Let's get the stationary points, the nature of the stationary points. So how do we do that? We get a sign diagram of the derivative. So first thing, let's get the derivative. That would be 12x cubed minus 48x squared plus 48x. Okay, what would I do here? Take 12x out as a common factor. That would leave me with 4x plus 4. Okay, then if I was to factorize this quadratic, factors of 4 that add to negative 4, it's going to leave me with factors of 4 are negative 2 and negative 2, so it's x take 2 squared. Okay, now sign diagram of this, critical value would be 0 because when x is 0 here the derivative becomes 0, so what's the critical value? And when x is 2 here, 2 take 2 turns the whole derivative to 0, so 2 is the other critical value. If I substitute in, say if I sub 1 in here, it'd be 12 times 1, which is a positive. If I sub a number greater than 2, I get a positive answer. If I sub a number less than 0 into here, I get a negative answer. Okay, so what does that tell me? It tells me I have a minimum at 0 here and a point of inflection, because the signs change stay the same, at 2. So I'm going to be dealing with something like this. It's a minimum here and then a point of inflection, because tangent is still horizontal here because the derivative is 0, but because the signs stay the same, it does something like that. Okay, alright, so what are the y coordinates for this, for these two stationary points here? Well, what I do is I go sub 0 into the first equation at the top, so f of 0, you can see all these will cancel out and give me an answer of negative 9. Okay, and then if I subbed 2 into the top equation, it's going to be 3 multiplied by 2 to the power of 4, take 16 times 2 cubed plus 24 times 2 squared, take 9. That is going to give me an answer of 7. Okay, so what I know is this. I know I have a local minimum at, what was it, 0, negative 9. And I have a horizontal inflection at 2, 7. Okay, so local minimum at 0, negative 9, sorry about the writing there, it's 0, negative 9, and a horizontal inflection at 2, 7. Alright, let's take a look at other points of inflection. So let's look at the second derivative. So second derivative would be equal to 36x squared minus 96x, so I'm using the first derivative, okay, minus 96x plus 48, okay. Let's take out 12 as a common factor there. It's going to leave me with 3x. Subtract how many 12s and 96? 8. 8x plus 4, okay. What would this, so if I factorize this, how would I factorize this? Well, I could split the x terms. 3 times 4 is 12, factors of 12, negative 8, etc, etc. That would give me x take 2, 3x take 2. So I split the x term there. I'm not going to show you how to do it because you should know how to do it already. Okay, so this would have a sign diagram. Critical values would be at 2, because 2 take 2 turns the whole thing to 0, and 2 on 3. Okay, 2 on 3, because change something. So 2 on 3 is one value, 2 is the other value. Okay, and if I sub some numbers in between these, so let's sub in 0, that's going to give me a positive answer. If I sub in 1, I'm going to get a negative answer. I'm going to get a positive answer. So, because these signs are changing about this point, these are points of inflection. Okay, so you can see that it's going to be concave up here, concave up, concave down there. Okay. All right. Now, I already know one point of inflection because I did it up here. It was at 2, 7. So I need to get what the y value of this point of inflection here. So I do f of 2 over 3. So that's going to be, I sub it way back into the first function. So 2 on 3 to the power 4 minus 16, 2 on 3 cubed it was, plus 24, 2 on 3, what was it, squared, and then take 9. Okay, so that gives me an answer of this. Okay, so therefore, let's go on to another piece of paper here. So that's the other point of inflection, 2 on 3 negative. So what I've found out is I've got a horizontal point of inflection. I'll just write it like that. Inflection. What was it? It was at 2, 7, wasn't it? And then I've got a non-horizontal. I can't write. Point of inflection at, what was it? It was 2 on 3 negative 2.48. Okay, so they're my points of inflection. Okay, now, when was this function increasing and decreasing? What do you use to find out? Well, you use the sign diagram of the derivative, don't you? And that sign diagram was this. It was, we had, these are our critical values, and it was doing this. So you can see that the f of x is increasing at x greater than or equal to 0, because it's increasing here, and it's decreasing at x less than or equal to 0, because here's where it's decreasing. So that's where the intervals at which it's increasing and decreasing. How do I know where it's concave up, concave down? Well, that was the sign diagram of the second derivative, wasn't it? And that sign diagram looks something like this. It was 2, and we had, what was the other one? 2 over 3. And we had these signs here. So therefore, f of x is concave up, okay, at, or 4, doesn't really matter, so concave up, x is less than or equal to 2 on 3, and here x is greater than or equal to 2, and it's f of x is concave down, what is it, between 2/3 and, so I'll write it like this, it should be x greater than or equal to 2/3 less than or equal to 2. Okay, so how do we put this all together and draw a little graph? Well, how do we interpret it? So let's just do, which way should I have the paper here? Let's just do it this way, all right? Just a quick sketch. So if this is my these are my axes, okay? I know that I had a local minimum at, what was the local minimum at? Let's think, it was, there you go, remember that, at 0, negative 9. So let's just say 0, negative 9's down here. Okay, it's a negative 9, so that's going to be my minimum. Okay, I know that it was decreasing at that point, so I know it's coming down here, going up. And then we found that there was a non-horizontal point of inflection at 2/3, negative 2.48. So let's say that was 2/3 here, negative 2. So non-horizontal, so it's going to do something like this. Alright, non-horizontal. So it doesn't actually, the key is it doesn't go like this. It's just, see how it's changing from concave. See, this is the point at 2/3, okay? So see how it's changing from concave up to concave down. And then we said there was a non-horizontal at 2/7. So 2/7, let's just have, so it goes like this. This is very rough, but you just need to get the idea. So you can see this was the non-horizontal point of inflection at that there. This is what your horizontal point of inflection looks like. don't worry that that doesn't match the axis, that's alright. And my minimum was there. You have to just understand what's going on. So I had a minimum, I had a non-horizontal point of inflection, okay, so it doesn't go like this, it's just changing from concave up to concave down, okay, and then here is where I have my horizontal point of inflection, so that's my graph.